Hey, good morning. How are you guys doing? Welcome. This is take number 10. No, I keep having problems. I keep messing my video up. But good morning, Maggie. Good morning, Jonathan and Marcus. I hope you guys had a good weekend. Tried to touch base with everyone last week to see how you were doing on your assignments and stuff. I hope you're doing well. This week, we're going to learn some really cool formulas. One of them is the distance formula, and the other one is midpoint formula. They are just really, really cool formulas. And so we're going to be doing some calculations in the coordinate plane, and we're even going to use the computer to help solve it. So I think you'll really like that. Now we'll do it by hand algebraically, but also I'm going to show you a really neat tool online that you can actually do some geometry in, and I think you'll really like it. So get your computer ready and let's get started. So today we're talking about distance formula, okay? So in today's lesson, we want to be able to find the length of a line segment in the coordinate plane. So it could be that I'm given a graph and I have a line segment given in the plane, and then I calculate the distance between the 2 points. Or it could be I'm given 2 coordinates and I have to find the length of the segment just from that given information with no graph. Oh no, how are we going to do that? Oh no, help us. Well, to be able to find the length of a segment, we have a special formula, and it's called the distance formula. And it looks like this. You have the distance is equal to the square root of the first quantity. Whatever, people, they're interrupting my video. You have the first one, x2 minus x1 quantity squared. So that's the difference in the x values of the 2 coordinates. And then plus the square of the difference of the y values. Okay, I think you're going to see something in just a second. And you're going to be like, I know how to do that. Because you've done it before. So really this isn't anything new, but the formula is new, because it looks a little bit different than the formula you used before, because we've made it more general to just incorporate the endpoints of the line segment. So here is an example of this formula in use. Okay, and we're going to do some. I'll help you through some, but this one's worked out for us. But I want you to look at this real careful. Okay, you're given these 2 blue points. Those are actually called our endpoints of the segment. And each of those endpoints have a certain x and y value. So we're going to come over here and I'm going to label that for you. So we're going to say this first point down here has the coordinate of 1, 0. And this point up here has the coordinate of 4, 5. Okay? And what they've done is they've said, let me see, their x2 is 4. So they've labeled each of these x1 and y1. Okay? And they've labeled this one x2 and y2. And they simply substituted into this formula and did their calculation. They took the difference in x values, 4 minus 1, and squared it. That's 3 squared. And 5 minus 0 and squared it. That would be 5 squared. And then to finish it out, well, you guys just do that. You know, you got square root of 9 plus 25. So D is equal to the square root of, what's 9 plus 25? Y'all help me out. Well, 25 plus 5 is 30, plus another 4 would be 34. Okay? And so your distance here is the square root of 34. Now, I asked you a question on this slide. Does this remind you of something? And I hope you're saying, yeah, of course it does. Because this is just sides, and I'm going to write this in a different color. Hot pink. Oh my gosh. A, B, and C. Are you cluing in? Have you figured it out yet? Yep, it's the formula a squared plus b squared equals c squared. And I want to show you something. If I solve for c on this formula, then I take the square root of both sides. So C is equal to the square root of a squared plus b squared. So do you see on here that this is your a squared and this is your b squared, and D is just your C? You are doing Pythagorean theorem. Did you get it? Pythagorean theorem is the same as doing the distance formula, but we've made it more generalized to just incorporate the endpoints of the line segment. So now we can do Pythagorean theorem in the coordinate plane. So again, if I'm given a graph, instead of doing x2 minus x1, I could just as easily come over here and say this is 1, 2, 3 units long. This is 1, 2, 3, 4, 5 units long, and plug those into the Pythagorean theorem and calculate the distance of the line segment. Very easy. Okay, you guys have done this before. Just not use the distance formula. So here we want to know the distance between the 2 points. And they've given us our x and our y values for both points A and B. And so we're going to set up the formula, but I'm also going to show you how to set it up using Pythagorean theorem. Okay? So if I label these points, I can say this is my x1 and my y1, and this is my x2 and this is my y2. Maggie, this color's for you. I don't normally use hot pink. But anyways, let's do it. We got distance equals the square root of x2 minus x1 squared. By the way, guys, doesn't matter which x I put first here because I'm squaring it. So if I do x2 minus x1 or x1 minus x2, it does not matter. Not on this formula. And then I get y2 minus y1 squared. And so we're going to substitute everything that we know into this formula. Our x of 2 is equal to a 4. Our x1 is equal to a negative 3. And I'm going to put that in parentheses, like I always do with my negatives. And then y2 is 6 minus y1 is 2 squared. And I'm taking the square root of all this. So I get D is equal to 4 minus a negative 3. That's 4 plus 3. So I get 7 squared plus 6 minus 2 is 4 squared. Okay? So D is equal to the square root of 49 plus 16. How do I know what that is, guys? Well, 49 plus 1, if I take 1 off of here, okay, I would get 50 plus 15, which would be equal to 65. Square root of 65. Okay? And guys, I'm not going to worry about simplifying that, but if I were to come over here, right here, and I go on Desmos, then I can do equal to the SQRT, and it'll give me my square root, SQRT, so equal to SQRT, 7 squared, hit the right arrow to get out of the exponent, plus 4 squared, and I hit enter. I made a boo-boo. I don't want the equal sign, guys, because I'm doing a calculation. I use the equal sign in a spreadsheet. So I have been on spreadsheets all day. But here we get 8.06. Okay. And, erase that. Here we get 8.06. 8.06. All right. Is our distance. Okay. Now, again, can I count this? Can I count it? Yes. Yes, you can. Okay, I can draw my right triangle if I can find, there it is. It's hard to see my cursor on here. Okay. So if I draw my right triangle there, I hope you can see that. This is 1, 2, 3, 4. and this is 1, 2, 3, 4, 5, 6, 7. So do you see I would do 4 and 7, and I would still be saying for Pythagorean theorem 7 squared plus 4 squared, which is exactly what we got up here using the distance formula. So again, if I'm in the coordinate plane and the points are nice, they're not always nice, sometimes they might be decimals, so you'll have trouble doing Pythagorean theorem in those cases. But in this case, we have nice behaved points, and you can do Pythagorean theorem if you choose, okay? But definitely know how to use the formula as well. And in a little bit, I'll show you how to do this on a certain piece of software. We'll talk about that in a second. So here I want to try another one. I want to find the length of this segment. And I say for this one, let's just do Pythagorean theorem on this, okay? So we're going to draw our right triangle. So let's do this and draw this down. Again, that's a right triangle because that's a 90-degree angle. And I'm going to count the sides. I have 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow. Do my eyes deceive me? Guess what did we do wrong? Yes. There's a little bit of foolery around here. Let's erase these distances because look at the scale on the axes. Look at the scale. Every block does not represent 1 unit, as every 2 blocks represents 1 unit. So here I have 1, 2, 3, 4 blocks, but if I divide by 2, that gives me a 2. So this is actually 2 units here. And whereas I had 12 blocks across, well, every 2 units is equal to 1. So actually, this is going to be a side measure of 6. Okay? Be very careful that you check the axes. Check your x-axis and the y-axis and look for the scaling. Okay? So this one about tricked us up. Okay? I about told you wrong. So we're going to say the distance here, D, is just equal to the square root of 6 squared plus 2 squared. Okay, because we're doing Pythagorean theorem, and this is basically c squared equals a squared plus b squared, but we're square rooting the a squared plus b squared to give us c, and that c is equal to our distance d. So here d is equal to the square root of 36 plus 4. So d is equal to the square root of 40. Hey Brutus, how are you doing down there? And this is 4 times 10. So if you guys remember how to simplify a square root, I'm going to take this 4. I can take the square root of that and bring it outside. So that square root of 4 is just 2. And then that 10 stays underneath. So that's 2 times square root of 10. Or if you like, you could do the decimal form. On your assignment, I'm not sure what it's going to ask for. I still got to set those problems up. But, you know, be able to do either way. Be able to recognize the square root form or the decimal form. Okay, so let's move on. All right, so I have one for you to try. Okay, so I want you to hit pause right now, and I want you to try and set up this problem. I'm not throwing you a curveball. If you look at the axes, every block is just 1 unit in length, so you shouldn't have that issue to deal with. But if you want to draw this on your paper, that's fine, or just count the blocks on your screen, but don't draw on your screen. It won't come off. Okay? But hit pause right now and try and work this problem, and then we will try and work it together and check your work. Okay? Thanks. All right, welcome back, guys. I hope you did well on this problem. Let's see how you did. Again, we're in the coordinate plane, so I could very easily draw my right triangle. Okay, and I hope if you couldn't draw this on your screen that you use your imagination, okay, and just imagine that triangle there, okay? And then I want to count the distances on my side measures. So I have 1, 2, 3, 4. Wow, that seems to be the theme today. And then here is 1, 2, 3, 4, 5, 6. So that is a 4 and a 6. So if I do my Pythagorean theorem, and I'll do it from scratch here, okay? That way you know what I was talking about on the last slide. I'm going to square root both sides of Pythagorean theorem and get C is equal to the square root of a squared plus b squared. Now I hope you'll see that your A is equal to 4, your B is equal to 6. Okay? Doesn't matter which one I call A and B. It's just the leg measures. So C is actually equal to the distance here. It's your hypotenuse. It sits across from the right angle. So I'm going to plug in D is equal to the square root of A squared. A is 4. Plus B squared is 6 squared. And I get D is equal to the square root of 4 squared is 16. 6 squared is 36. So let's see what we got. What is 16 plus 36? Wow. Well, an easy way to do this mentally, I'm going to come over here and do some mental math, is I can treat this as 10 plus 6 and 30 plus 6 and add these together. 10 and 30 add up to 40, 6 and 6 add to 12, and 40 plus 12, this is 52. So we're going to put 52 right there, okay? And so that is our distance. And I'm just going to stop there, okay? So we'll say that's our distance. And let's move on for sake of time. I don't want you to be here all day just watching a video. Now we want to look at a case when we don't have a graph. What if there's no graph? Well, guys, I can still do my theorem, okay? All right, so I'm still going to label my points, okay? I'm given the point -5, -4 for point P, and Q is at 4, 7. If I want to find the distance between the points, I'm going to use the distance formula, but I'm going to label my points x1, y1, and x2, y2, okay? And I know my distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And my hand is going numb. Good gravy from holding this pencil. Oh. So I get D is equal to, and we are going to substitute everything that we know. X of 2 over here is equal to 4. Minus x of 1 is equal to a -5 squared. Y2 is equal to 7 minus y1 is a -4. I give y'all very pretty numbers this time, did I? So D is equal to the square root of 4 minus 5 is 4 plus 5, so that's 9 squared. And 7 minus 4, or minus a -4, is 7 plus 4. Well, that's equal to 11 squared. So we get distance is equal to 9 squared is 81 plus 11 squared. You guys remember your multiplication tables? What is 11 times 11? Think about it. Do you remember? It should be 121, okay? Now, again, if you ever have your doubts, come over here to Desmos and type it in, and you get 121, okay? So you can still check yourself on your calculator, all right? And I do that sometimes. Okay, maybe it's because I'm getting old, I don't know. So here, what is our distance? We get square root of 81 plus 121. Okay, I'm going to come off to the side over here. 81 and 121. I add these together. 1 plus 1 is 2. That's 10. So that's 202. Okay, so that would be your distance. And we can box in our answer. Okay, and there you go. All right, so let's see what's next. Okay, I asked you to try this one. Okay, so I want you to try and work it out. I want you to get your distance, and then I'm going to have you hit play, and I'm going to show you how to do this on a piece of software that maybe you haven't tried yet. You might have heard of it. Maybe you've been on it before. I'm not sure. But try and do the distance formula on these 2 points and find the measure of segment RS, and then hit play, and we'll continue on with a piece of software that I think you'll find really cool. So you hit pause now and try and work it out on your paper. Thanks. All right, guys, welcome back. Let's see if we can work this problem out and do this on another piece of software. So I'm going to go back over here. I'll have to refer back to our points here. But we're going to look at a piece of software called GeoGebra. Okay? The website here is geogebra.org. Okay? So let me write that out for you so that you can actually see it. I'm losing my pen here. It is called geogebra.org. Okay? So if you want to pause the video real quick and open up a browser window and type that address in, it should take you to this website here, GeoGebra Math Apps. Now you can sign in over here using your Google account, and that's fine, or you can use it generically. But I want to look at the graphing calculator. No, scientific calculator. I really want the classic. There it is, GeoGebra Classic. That is the one I like. Okay, it's right under More Apps, but this is the one that I typically like to use. Okay, and it may take a little bit for it to load, so just give it a second. So you get this nice little workspace. Okay, you get a coordinate plane. There are some other things over here. I can do 3D graphics, computer algebra system, spreadsheet, probability, whatever. But again, I'm just going to click on here, and notice these buttons at the top. Okay, I have points. I can actually click on points in the coordinate plane, or I can type them in. And since I don't remember the notation for typing them in, I'm going to try notation. If it screams at me, no problem. I can retype it. Okay, so let's go back and grab one of our points. So I'm going to switch back over. We have point R is -1, 3. Okay, so I'm going to try typing R as -1, 3. And see if it takes it. And it says unknown command R. Well, that's because I didn't remember the notation, and I think it requires us to type an equal sign. And yes, that's the case. So R is -1, 3, and you notice it plots the point for you onto the coordinate plane. And now we want to put in our other point, S, which is at 1, 2. So we're going to do capital S equals parentheses 1, 2, and hit return. Now there is your 2 points, and I want you to zoom in. So if you have a scroll mouse or something, you can actually scroll in. You can probably also do Control+. Yes, you can, to zoom in on that. And then over here, I want you to look across the top. Do you see anything that might help us? We're trying to find the distance of a line segment. And I look over here and see this right here has a line going through 2 points. So I'm going to click on that. And yes, look right here. It has an option for segment. Okay. And it also has segment with a given length. That's when I want to tell it how long I want my segment. But I'm not going to do that. Okay, we actually have a segment defined by 2 endpoints. So I just want to click on segment and then click on the first point and drag to the second point and click on the second point. And there is your line segment. And look, guys, they've already told us the distance of this line segment is 2.24. So I hope you guys got that on your problem. So you should have RS, the measure of RS. If I have RS, let me write this up top. RS with a line over it, that reads segment RS. Okay? If I have just RS with no line over the top, that is read the measure of, I can't write good, but measure of RS. Okay? So here I'm saying the measure of RS is equal to 2.24. So it's giving me the decimal value of that, and that's okay. All right? So if I wanted to write this out, if you didn't get 2.24, then I'm going to show you how to write this out. I don't want you to just feel like I left you out on that. So we're going to label these like you would have, x1, x2. Please don't write that. We're going to write down x1, comma y1, and x2 and y2. Okay? So our distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. By the way, guys, you need to memorize that formula. Okay? That is something you should commit to memory. And I have x2 is equal to 1 minus a negative 1 squared plus y2 is equal to 2, not comma, let me back that up, 2 minus y1 is equal to 3, and that's squared. So my distance is equal to the square root of 1 minus a negative 1 is 1 plus 1 is 2 squared, and 2 minus 3 is negative 1 squared. Okay? So basically I get d is equal to the square root of 2 squared is 4, negative 1 squared is 1. So I get d is equal to the square root of 5. And if I go back over here to Desmos and I type in SQRT of 5, then indeed we get 2.236, which does round to 2.24. Okay, so that is correct. And I hope you guys were able to get that. If not, try working through it again, doing your substitutions, and see if you can get the correct answer. Okay? So in summary, guys, today we learned how to use the distance formula, and it is derived from the Pythagorean theorem. And I hope y'all saw the connection when we were looking in the coordinate plane. And the distance formula is given over here on the right. It is d equal to the square root of your difference in x value squared plus the difference in y value squared between the 2 points. I do want you to commit this to memory. When you're doing distance formula, you should be able to just write it out and then substitute your values. I would certainly want you to label the points 1 and 2, label them x1, y1, x2, y2, and then substitute into the formula. And be sure that you use your parentheses. Okay? If you try and substitute without parentheses, one, it can mess you up. Two, if I plug in a negative, I may confuse my negative with the minus sign and also get the wrong answer. So be very careful doing your substitutions. And I hope you guys enjoyed the lesson today, and I hope you will do very well on your assignment. So hit me up on Google Hangouts if you have any questions, and I'll be glad to help you. But enjoy, and hope you have fun calculating your distances. All right, signing off.